till the point of average EMF we have calculated. Yes or no? Right or not? After that, again in this question, now write the question for this particular thing. Okay. Now what it is asking, that if the resistance is R, what it is saying, if the resistance means in this loop the resistance is how much? R, then you have to calculate there, find the charge flown, find the charge flown, or find the charge flow in time t is equal to 0 to t is equal to, like let's suppose 2t seconds. Do it. Hey, do not talk. What it is asking? If the resistance of this particular loop is R, right or not? If the resistance of this particular loop is R, you have to calculate that how much charge in this particular loop. Since there will be some kind of current induced, there will be some current that will be induced in this particular circuit or not? Tell me, sir, no? You have to calculate that with the respect to that induction of that particular current. That is whether it is in okay, current is inside. So again, magnetic field is inside, current will be clockwise. So how much is the magnetic field? How much is the charge that is going to flow from t is equal to 0 to t is equal to 20 seconds? Do it. Rakshita, which formula I will use? And why, Rakshita? How much marks you have got? Huh? 29. What you did? Huh? What you did really? Tell me. Should I tell to CKR sir that she didn't have revised anything, whatever I have given as homework? Dhanush ke marks are more than your marks. And really good. I appreciate your efforts. Highest is 114. After that, 97. Shreya. HM? 93. Why HM in 93? Huh? Why you are not solving the problems in the exam properly? Huh? You are not solving. You are taking less time to think. Take some more time. 30 seconds or 40 seconds extra. What HM? What you are doing? Do this problem. Rakshita, tell me how to solve this problem. How to calculate the charge flown? Huh? First, what is required? How to calculate charge flown? Charge will flow when the current will be established, yes or no? So dq is equal to I dt, yes or no? I is equal to EMF by R into dt. What is your EMF that was getting? M B naught B square into omega sine omega t into dt divided by R. Yes or no? These all are my constants. Sit down. So how much will be the charge flown? Integral dq will be equal to m b naught b square omega divided by r into integral 0 to 2t into what? Sine omega t dt. Got it or not? Yes or no? Now 0 to 2t sine omega t is again how much it is going to be? This is going to be, look over here. It is again a double time period or not? Yes or no? From 0 to 2 sine, like look over here. If it is 2t, that means what? From 0 to 2 the sign will be positive. From t to 2t it is going to be negative or not. So if I take the integration from here to here, what will be the total curve length? 0 or not? Area of the curve will become how much? 0. So therefore what it is going to be? Answer will be equal to the total charge flown within this time is how much? 0. Got it or not? So here is this done or not? Okay. Next question is, find the heat generated during this time interval only. Right or not? Since this loop has some kind of current in it, what you have to calculate? The heat generated in the time interval the heat generated in the time interval t is equal to 0 to t is equal to 2t. Now do it. Is it going to be 0? Is it going to be 0? Is it going to be 0? No. Heat generated will not be 0. Heat will be definitely generated if there is a current that is established. Got it or not? So heat formula is what? H is equal to I square RT. Yes or no? I can be written as EMF by resistance or not? So EMF square divided by R square into R into T or not? R got cancelled. So what I got as heat EMF square by R into. But this heat we have to do from integration or not? Why? Because for every small time interval there will be different heat. So I'll have to convert it into differential. For dH is equal to integral E square by R into dt. Right or not? What is E square now? So M square magnetic field, B naught square also, B to the power of 4 omega t square sin square omega t into dt divided by resistance R. Right or not? So heat will be equal to how much? I'll take common M B naught square B square omega square divided by R to be common integral 0 to 2t sin square omega t into dt or not? Tell me yes or no? Or yes or no? Now is this value is going to be 0? Is this value is going to be 0? The answer is no. Why? So you can use capital T as 2 pi by omega. There is a relation now. Omega is equal to 2 pi T or not? Or yes or no? 2 pi by T or not? Omega is equal to 2 pi F. Frequency. Omega is equal to 2 pi F. Frequency is 1 by time period for one oscillation. Right or not? So omega will be 2 pi by T or not. So 2T means what? First time it will go to the extreme condition, then it will again return back. Right or not? Are you able to get me or not? Guys, can you solve this? Sin square omega t. How to solve? 0 to 2t sin square omega t dt. What I will use? Which formula I am going to use? 0 to 2t. Which integration trick I will use? Sin square omega t. How to solve sin square omega t? Can I write 1 minus cos 2 omega t divided by 2 into dt? Yes or no? Or yes or no? It will give you 2 sin square omega t or not? So 0 to 2t 1 by 2 dt minus 0 to 2t. See, I didn't means it's been 6 years since I used mathematics. 2 omega t divided by 2 into dt. Got it or not? So this will be what? Only t over here. So this I'll get 2 1 by 2 2t I will get or not in this plus 1 by 2. What is the integral of cos theta? Mine only sin theta. So sin 2 omega t divided by division, it will come or not? Or in differentiation it is multiplication, in it is division. It will come as 2 omega over here. Yes or no? 0 to 2t. Right or not? T plus half. So now look over here. Okay, make it 4 omega. Okay, sine into 2 into omega is what? 2 pi by t, and this t will replace by this variable or not? 2t, yes or no? Minus 0 it will come. Now t got cancelled. This is how much? 6 pi, and this value will become how much? 0. So this whole term is 0. So how much you got? T over here. Right or not? Or yes or no? So can I replace over here that heat generated is m into b naught s square b4 omega s square divided by r into what? Type t. Right or not? M square. Yes, this is M square. So time period is what? 2 pi by omega. So this whole answer will be what? M square b naught square b4 omega divided by 2 time is equal to 2 pi by omega. Okay. So this will be r into 2 pi. Right or not? Can you do next question? Should I move to next question or not? Now in your options you might see that this whole term is given as something like this whole, you will see the answer given as 2 pi into, actually the answer is given in terms of E naught s square divided by omega r. Now what is this E naught? E naught you have calculated that when you calculate EMF, is it in terms of something like sine omega t or not? Tell me yes or no? Or yes or no? So you will get over here some kind of sine omega t. So some term is over here or not? That term is called as E naught. It is called as amplitude of the oscillation or something like that. Right or not? Yes or no? So in your exams, do not get confused. Just see what is the term before some kind of periodic functions. This sine omega t, cos omega t are called as periodic function. Whatever the term is before that these periodic functions, just those are the amplitudes. Right or not? And that can be represented as E naught or something like that. Got it or not? Okay. Moving to next question. What it is saying that you have a conducting rod which makes an contact with the metal rail AD. Right or not? Which are 0.5 meter apart. If uniform magnetic field of induction 0.5 Weber per meter square acts perpendicular to the plane of figure. Calculate the magnitude and direction of induced EMF when the rod is moving to the right with velocity how much? 4 meter per second. Means this rod is moving towards this right with how much velocity? 4 meter per second. Then you have to calculate the EMF generated. Do it fast. Do it. How to do this question? Have you ever tried this kind of questions or not? Does this loop has some kind of resistance or not? How much is this resistance? It is given in the second question. Okay. So I'll show you how to do this kind of problem. So first of all, for we need to calculate the flux or not. Whatever we have to, if we want to know the EMF, we need to have the flux definitely. Right or not? For flux, we need magnetic field, which is given already. But do we have area? No. Do we have area? No. So let us consider that this AB is located at distance x from this end of the wire. Right or not? At where it is located? At distance x. Got it or not? Where it is located? Distance x from this wire. Got it? Or yes or no? So now look over it. Now can you define the flux or not? This will become a square loop or not? Tell me yes or no. If it is also not a square loop, let us consider that the length of this rod is how much? L. Let us consider that this AB length is how much, guys? It is equal to length L. Right or not? Sir. Yes or no? So now look over here. Flux can you define or not? Flux when it is at distance x, it will be equal to what? Magnetic field into area. Area is what? Length into breadth or not? Which is L into x. Right or not? Sir. Yes or no? It will be equal to V into Lx or not? Tell me yes or no? Sir. Now magnetic field is making 90 degree with the areas, 0 degree with the area, so therefore cos 0 is how much? 1. So now look over here. EMF is equal to what? Minus of d phi by dt. Got it or not? Sir. Now, which is equal to what? Minus of d phi by dt means what? D by dt of B into Lx. Got it or not? How much I get? B into L minus of B into L into what? Dx by dt. Is I'm going to get this or not? Or yes or no? Sir. Yes or no? Yes. So look over here. What is the EMF generated? Now dx by dt is the velocity of this rod or not? Tell me yes or no? Or yes or no? Sir. So that dx by dt is going to be how much? Minus of b is how much? 0.5. Length of the rod. If the conducting rod AB makes a contact with the metal rod AD, which are AD and BC. Now look over here. See, look over here. There is a little bit of confusing question which is given. That the distance between AD and BC means distance between this AD and BC is what? It is the length of rod AB or not. So that length is given how much? 0.5. So into 0.5 into dx by dt, which is your velocity, this is how much? 4. 10 down, 10 down. So that means what? It is equal to how much? 1 volt. How much is the EMF generated? Minus 1 volt. Right or not? Yes or no? So here, what is generated? EMF is generated or not? So can we call this as generators? Can we call this as generators or not? And which kind of rule I will use? Left hand rule or right hand rule? Generator it is right hand rule. For motor it is left hand rule. Fleming's left hand rule for motors. For generators, Fleming's right hand rule. Right or not? So now look over here. Magnetic field is inside. How I'll use FBI again? Simple. Hey, look over here. Right hand also it is rule is same. FBI. Force, magnetic field and current. So magnetic field is inside or not? Tell me yes or no. Inside towards the paper. Where is the force? Force means what? Velocity of the particles. So where is the current is going to get produced in that rod? In the upward direction. So therefore, current is produced in which direction? Upward direction. Right or not? Understood? Or yes or no? Are you able to get me or not? So now look over here. One thing is problem that although the magnetic field is inside, if we see that for the magnetic field inside, how the current should be developed in a clockwise direction or not. But here the current is developed in which direction? Anti-clockwise direction. and that is why your EMF is actually negative of dx by dt. This is the reason we use negative sign over here. Got it or not? Are you able to get me or not? Why? Because it is just opposite of whatever the cross product between magnetic field and the velocity or something like that is there. Got it or not? Are you able to get me? So you can see magnetic field is along plus z axis, or you can say plus k. Okay, we'll do it later when we'll go emotional game. Okay, understood. Second question, what is asking? If the resistance of the circuit is 0.2 ohm, calculate the force required to maintain the motion using smooth contacts. Good. So now look over here. This is a very trivial question. It has asked the force, something which is not understandable. So now look over here. I'm erasing this part. Okay. How much is the EMF generated? 1 volts. Yes or no? EMF generated is how much? 1 volt. So therefore current generated will be what? EMF by resistance. EMF is how much? 1. Resistance is 0.2. So is 5 ampere that will be the current generated or not? So in this, try to understand, in this rod how much is the current generated? 5 ampere. 5 ampere. So now look over here. If the current that will be generated and there is a magnetic field, also the length of conductor is known. So do not sleep, yaar. So therefore, what will happen? Some kind of force will be generated, yes or no? Are force will be generated or not? Now that force will be due to the magnetic field on the current carrying wire, yes or no? How much is that force that is generated if on current carrying wire is how much? B into I into L, yes or no? Or yes or no? Now B is where? Inside it. B is where? Inside it. Current is moving upwards. So B is if BI. Now look over here. When I am calculating this force using BIL, I will shift my hand from right hand to left hand. Why? Because now we are talking about motor case. That how much force is generated due to the current. Void or not? Yeah. Or yes or no? Are you able to understand the shifting or not? When I was required to find the direction of current, I used right hand. When I am asked to calculate the direction of force, I am using left hand. So magnetic field is inside. FBI again. Force, magnetic field, current. Magnetic field is inside. So middle. What is this finger? What this finger is called? Index finger. So index finger should be going inside. Right or not? Current is upwards. So where is the direction of force? Towards left side or not? So therefore, this wire is experiencing in which direction the force? It is experiencing towards right side. Where sorry, it is experiencing this FBIL towards which side? Left side, which is equal to how much? 0.5 into current 5 into length is how much? 0.5. So how much is the answer? 1.25 newtons is the force which is present towards right. So therefore, how much force should be present towards left right side? Guys, how much force should be present towards right side to make it move always? It should be equal to how much? 1.25 newtons. Right or not? This force definitely should be there so as to move with the constant velocity of 4 meter per second. One of the most trivial cases. You are moving with constant velocity, but still what is present? Force is present. So that means what? Is the acceleration is present? Is the acceleration is present or not? Now that acceleration, let's suppose the mass of rod would have been given. So this mass of rod is equal to what? M. So M of rod into acceleration A is equal to what? Force applied over here. So can you get the force due to induced current by mass of rod as acceleration or not? But this acceleration is making the rod to move with constant velocity always. Why? Because there is an opposite force acting on it. Got it or not? Got it. So first case is there. Every time whenever there is a constant velocity, acceleration is 0. But here constant velocity is there, but acceleration is not 0. Got it or not? Question number C, do it. What question number C is saying? Compare the rate by which mechanical work is done by the force with the rate heat dissipated in the circuit. So what it is asking, compare the rate at which mechanical work is done. Now, rate of mechanical work means rate of work done by time taken. This is called as rate or not? Tell me yes or no. What this is called as? Power or not? Array, is this power or not? Now, this work is done by this rod by some kind of applying force, yes or no? So, can I say the work done divided by time can be given as force into velocity of rod? Yes or no? So, power that is required over there is how much? Force into velocity. So, power is how much? Force is how much? 1.25. Velocity is how much? 4. So therefore it is equal to how much watts? 5 watts. So therefore rate, that is rate of work done, rate of mechanical work done by the force is how much? 5 watts? Or yes or no? Now calculate the heat dissipated. Heat dissipated due to this movement is how much? I square RT. Yes or no? Or yes or no? So can you calculate? Okay, it is asking about again rate of heat dissipated. So rate of heat dissipated will be what again? So let us consider this quantity to be x. It is going to be I square RT divided by T or not? Tell me yes or no. So rate of heat dissipated is how much? I square R, which is also called as power. Right or not? Or yes or no? So rate of power of heat dissipated is how much? I square R. Current developed is how much? How much is the current developed? 5 ampere. So 5 square into resistance R 0.2. How much is the rate? This is, it is also equal to 5 watts. Got it or not? Got it or not? So that means what? That whatever the magnetic field is applying as a force to the rod, what does this mean? That whatever the magnetic field, see, this is the power which has been utilized to do the work. Got it or not? Hey, this is the power which is utilized to do the work on this particular current carrying wire, right or not? And in that current carrying wire, how much is the heat dissipated? It is also similar. So that means what? That let's suppose this wire starts to move with particular velocity of 4 meter per second. If the wire starts to move with particular velocity of 4 meter per second, it is generating some current in it. For that current, it is also pulled by some kind of force towards backside, but we need to pull it towards right. Now, this force which is pulling over here as a in the backside, this force is actually what this force is doing? This force is not this force is not helping anything, but actually this force is getting converted totally into heat energy. Right or not? Are you able to get me or not? What it is doing, this force is affecting this resistance and it is getting converted into what? Heat energy over there. Understood? Yes or no? Are you able to get me or not? Like that. Okay? 1.25? No? It will be 5 ampere. I is current is equal to EMF by R. EMF is 1 volt. Resistance is 0.2. Decimal will go up. So current will be how much? 5 ampere. Yes, current is 5 ampere. So now write in that, hence the work done by the force, hence the work done by the force applied to the rod, applied to the rod is completely converted, is completely converted to heat in the resistance. Is completely converted to heat in the resistance. These are some of the best questions. Okay. Slip manasa slip. Go on slip. Okay. Done. Yes or no? Okay. Mention next question. Others can go. These guys will go later. 5 minutes later. I'll Right. Write the question. What is saying? The space in this question, this is a very good question. Try to understand. The space is divided by line AD. The particular space, the whole space is divided by line AD. So this line AD is what? It is creating two kinds of space over here. This particular line over here, it is creating two kinds of space. One space, one, another space, two. Got it or not? What it is saying? In two regions, region 1 and region 1 which is of free field, means this region there is nothing over there. In region 2 has a uniform magnetic field directed into the plane of paper. So in region 2 what you have? Some kind of uniform magnetic field which is directed into the paper. Now ACD is a semicircular conducting loop of radius r. So what is this ACD? It is a semicircular conducting loop of radius how much? R over there, with center at O over here. Now what it is saying, the plane of the loop being in the plane of paper. Got it? Means if the plane of paper is like this way, magnetic field is inside this, loop is kept like this way only. Got it or not? What is the question it is asking? If the loop is now made to rotate, what we are doing? We are rotating this loop with some kind of angular velocity omega about the axis passing through O. Means there is an axis which is passing through O like this way. Got it or not? Okay, perpendicular to the plane of paper and parallel to the magnetic field. Got it or not? And we are rotating using that kind of particular axis. The effective resistance of loop is also given, which is capital R. Obtain the expression for magnitude of induced current in the loop. First question. Okay. Second question is show the direction when the loop is entering into region 2. And third question, draw the graph. Now look over here. In this particular question, what is happening actually? First of all, how the direction will be produced? How the current will be produced? Current will be produced only due to change in, like if the EMF is there and if the flux changes, then only the particular current will be produced or not? Yes or no? Then only the particular current will be produced or not? So that means what? In this question, what is going to happen? EMF is equal to, as you know, d phi by dt. So is the area is changing over here? Is the area of the loop is changing? No. What is changing? Magnetic field is changing. First, what is happening with the magnetic field? Means try to understand. First, if the loop comes over here like this way, got it or not? So only this much region is there or not? This much region is only have the magnetic field? Yes or no? So actually here many people will say that magnetic field is changing, but actually here area is changing in the magnetic field. First, little bit amount came when it starts to rotate. Then some more come. Means what will happen? This is my magnetic field. After some time, what will happen? Half of the part will come like this way or not? This part will be in the magnetic field. This part will be outside. Again, when it has rotated completely by 270-degree angles, what will happen? This will become like this way or not? Whole area is there in the magnetic field or not? So what is actually changing? Area is changing with respect to time. Right or not? So based upon that, you have to calculate the EMF, then you have to calculate the current generated in the process. Right or not? We'll do it later when we will have extra time. Got it or not? Okay.